Hi everyone. Today we're going to go over section 4.3. It says letter A, section 4.3a. However, there's only one section that we'll cover in 4.3, so you can ignore the A for now. This section is called trigonometric functions in right triangles. Alright, so we're going to be working with right triangles, and you guys will see a bunch of actual geometry coming back into play here, and then we'll go and add a little bit more than what you guys already know from geometry. But to get us started, we have this right triangle in front of us, and it's labeled with a bunch of A's and a bunch of C's. And what I want you to pay attention to is each corner has a capital letter A. So that capital letter is in reference to an angle. Okay, so those are labeling our angles. So we have angle A, angle B, and angle C. And then the lowercase letters, the side directly across from the angle is the same exact letter, but this time it's the lowercase. So lowercase letters and talk about the sides, the side lengths. Lowercase represents the side lengths. Whereas the uppercase, the capital letters, are going to represent the angles. All right. Now we know we're working with a right triangle, so that right angle is going to be right here. If it's not labeled in our notes today, we're just going to assume that's the right angle every single time. All right. And the side directly across from that right angle, we have capital letter C as the angle. The side should be the lowercase angle. And that right there is going to be called our hypotenuse. So every single time you see a right triangle, the hypotenuse is the side directly across from the 90 degrees. All right. And then we have what's called the adjacent side. And the adjacent side is the side, is the touching side. And I'll talk about that in just a second. I sometimes tend to get my adjacent sides confused. I've never really understood it, but hopefully I can explain it in a good way for you guys. And last but not least, we have the opposite side. And opposite side is the exact thing that we're talking about. It's the side opposite, or the side across from the angle. So technically, if you were to take the opposite side of a 90-degree angle, you would have the opposite side. However, that specific side across from the 90 degrees is always, always, always going to be our hypotenuse. Okay? The adjacent side. Let's mark this A here, for example. If I have this angle A, I know that the hypotenuse is still C because it's still it's still the side length across from the 90 degrees, but my touching side would be B. So my adjacent side to angle A would be the lowercase letter B. And then if I looked for my opposite side, it would be the one directly across from my angle, which was side lowercase a. All right. So when we talk about adjacents, opposites, and hypotenuses, that is where we are getting them from. So we have trigonometric functions, right? And if you just look through them first, we got sine, cosine, tangent, secant, cosecant, and cotangent. All right, again, you guys have seen 3 of these from geometry. The first 3, in fact, you have seen from geometry. And the last 3 are going to be interpreted a little bit differently, but believe it or not, you actually can work with this one and determine what's what from here. So to get started, we have cosine. And if you remember from geometry, you guys had what was called SOHCAHTOA. It's the same exact thing that we're going to be doing today. All right. So went with sine, ka went with cosine, and toa went with tangent. So before I get started on cosine, I'm going to take the ka portion. And this really helps you determine what needs to be used. So if I'm looking for cosine of angle A, I need the adjacent side on top. Remember, we're taking the A, and then I need to follow with the H down below, while our H was the hypotenuse. And then if we look back up at our picture here, it's referencing this picture, this triangle here. Erase what I had written prior. Okay, we still know we have that 90-degree angle. This is in reference to angle A. So I'm going to look back at angle A, and I'm going to say, well, what's my adjacent side to angle A? We have lowercase b. And then my hypotenuse to that was lowercase c. So we can fill out our equation based off of the picture that we have. Then if I move to sine, we're going to talk about so. So we have sine first, that's our S. Then O is going to tell us that it's our opposite side divided by our H, which again would be our hypotenuse side. Look back up on my picture. Same angle that we're talking about, so angle A, my opposite side to angle A is lowercase a, and my hypotenuse again is C. And we'll fill out the next one. We got tangent. Tangent is the TOA. So we have to remember that it's opposite side first, followed by adjacent side. Look back at the picture. We're still referencing angle A. My opposite side was A again, but this time it wants the adjacent side instead of the hypotenuse, so I get B. All right. So we have SOHCAHTOA completed. Now the remaining pieces, secant, cosecant, and cotangent, are the same exact things as what we just did, the top three that we just did, but now it's the reciprocal. It's the flipped version, right? So if I told you that secant is the same as the reciprocal of cosine, instead of adjacent over hypotenuse, we would have hypotenuse over adjacent. And we're still referencing the same triangle up above. So my angle is, my side lengths will be a C divided by B. And if you look up at cosine, it's the same exact values, same exact letters. It's just the flipped version. It's the reciprocal. So whenever you see secant, you want to think cosine. It's the opposite, the reciprocal version of cosine. So let's do cosecant. If it's not cosine, then it's going to be the reciprocal of sine. Look back at our sine. This time we want to put the hypotenuse up top, followed by opposite down below. And we will have C divided by A. And you'll never guess what cotangent is because it still uses the word tangent. It's just now the reciprocal of tangent. Okay, so we want adjacent first. Oops, if I can spell that correctly there. Adjacent divided by opposite. So my adjacent side is B, and my opposite side is A. So we're just filling out our 6 trigonometric functions and finding their angle or their respective sides. All right. And again, as a study tip, I gave you guys this thing here. SOHCAHTOA, remember it splits after every 3. S stands for our sine, which is opposite and hypotenuse. C stands for cosine, which is adjacent and hypotenuse. And then T stands for tangent, which is opposite and adjacent. SOHCAHTOA. If you know those 3, we can figure out secant, cosecant, and cotangent, just the reverse version of what we had from above. So then we have 4 problems here that we're going to try to work out. Okay, before we start these problems, we need to remember a theorem. Okay, more importantly, we're talking about right triangles, so if you remember your theorems, with right triangles, we had what was called a Pythagorean theorem. And we are only allowed to use this theorem with right triangles. And the Pythagorean theorem states that a squared plus b squared equals c squared. All right. Now, it just so happens that all of my triangles on this page are the letters A, B, and C, which is great. But pay attention, I'm not using capital A's, I'm not using capital B's, and I'm not using a capital C. I'm using lowercase. So in this theorem, we are referencing their side lengths. That is the only thing we can use this Pythagorean theorem for, is with the side lengths. So if you look at example 1, I gave you 3 parts of information. I told you that lowercase a equaled 1. So let's just add that in. As soon as we get information, let's add that in. And then lowercase c equals 3. And then we're going to say that capital letter A is my theta. That's the angle that I'm going to reference when I do my 6 trigonometric ratios. Okay? And of course, we know that this is a right triangle. It's not explicitly stated to us. But for this purpose, I will tell you this is a right triangle. All right. Now, if I know that I need to have all of my side lengths, I'm going to need adjacent, I'm going to need my hypotenuse, and I'm going to need my opposite. Take a look at what's not given right this second on this triangle. I have my side length A, I have my side length C, but I do not have my side length B. So before I even get started, I have to figure out what side length B is going to equal. And in order to do that, I have to use my Pythagorean theorem. So I have 1 squared taken from my lowercase a plus b squared, I don't know what that is, that's what I'm solving for, equals c squared, which was 3. Simplify really quick. 1 squared is 1, b squared will still remain, and 3 squared is 9. So I'm looking at b squared equals 8 when I subtract that 1 over. And then from there, I'll take the square root of both sides in order to get it to just say b and not b squared. And when you simplify this radical, this was on our last test, you're looking for pairs because you just took the square root. So I have one group of 2 that I can take out, with the square root of 2 going back into parentheses. And that, my friends, is our letter B that I'm talking about. So I'm going to fill that in now that I know it. All right. Now that I have now that I have all 3 side lengths, let's go ahead and do our 6 trigonometric ratios. So I like to start with sine. I know that the page before started with cosine, but I like the SOHCAHTOA reference, so that's why I always start with sine. So we're talking about sine theta, which I don't need the E there. So sine theta, which in our case is sine of angle A. But we will call it theta because they just labeled it as such for me. So sine theta. And I'm just going to write them all first, just so that I know what I have to fill in as I go. All right. Sine goes with cosecant. So So I'm going to keep those in line with one another so that that helps me later. And then cotangent we will call COT. So cosecant is CSC, secant is SEC, and cotangent is COT. All right, so let's get started. Again, if you need that reference on the front page, by all means, please use that. If you start with sine, you're looking for your opposite side divided by your hypotenuse. So right now, my opposite sine, again, we're referencing the theta here every single time. That's not changing. Opposite is going to be 1 divided by my hypotenuse, which was 3. Then we go to the cosine. Cosine is adjacent divided by hypotenuse. So we have my adjacent side, 2 root 2, divided by 3 again. And then we have my tangent. Tangent is going to be your opposite divided by your adjacent. All right. Now, if you look at this answer for your tangent, we don't really like that answer because we have a square root in that denominator. So let's practice getting the square roots out. So we're going to multiply it by another 2 root 2, multiply by 2 root 2. And that will give us 2 root 2 in the numerator divided by this 2 times this 2 is going to give me 4. And then when I take the roots and multiply those together, that will give me a 2. Well, 4 times 2 is going to give me 8. And then from here, it's just a simplifying game. You can take these 2 and 8 and simplify it to a 1 and 4. And so we have the root 2 divided by 4 for your tangent. That is what your tangent value will be. All right. And now the beauty of doing all of this is now that I've matched my other 3 trig functions to their respective reciprocals, I can just go back and do the reciprocal. So for cosecant of theta, well, my sine was 1 over 3, so my cosecant is going to be 3 over 1. All right. I understand 3 over 1 is technically 3, but since we're talking about opposites and hypotenuse and adjacents and those fractions, just leave it as a fraction for now. We don't need to worry about that simplification or anything like that. And I do the reciprocal for secant here, but pay attention to what happens yet again. All right. I don't like square roots in the denominator, so let's get that out. Same process, multiply top and bottom by 2 root 2. And when we simplify, this will give me, and I'm going to erase my work here, but when you simplify, your final secant value should be 6 root 2 divided by 8. We can, of course, simplify that to 3 root 2 divided by 4. Okay, a little bit different of values compared to the cosine version, but that's because we had to do the conversion of the square root. All right, and then last thing for the cotangent, when we flip the cotangent, go back to the original tangent. Don't worry about this root 2 over 4 because that's going to make you have to do that square root all over again, and we don't want that. So go back to the original version. And what's great about that is we now have 2 root 2 in the numerator and 1 in the denominator. So I don't have to worry about simplifying any of that because my root this time is now in the numerator. Okay. Go ahead and try question 2 on your own. Get started there. If you want to pause this video and see what you can get, go ahead and do so. That is all we are doing for today's notes, is just practicing SOHCAHTOA and getting all 6 of our trig functions. For question 2, we have to, again, label our values that they gave us. So C is 20. A is still my reference angle. That's my theta. And lowercase a is going to be 6. I can't seem to write that on my paper there, but there it is. So the side we're still missing is B. So let's go back. I'm going to put this at the top here so that I have plenty of room for my trig functions. Got 6 squared plus b squared equals 20 squared. Gives me 36 plus b squared equals 20 squared should be 400. Subtract that 36 to both sides and I get b squared equals 364. Square root both sides. And I'm looking for pairs. 364 gives me a, oh goodness, 2 times, what is that, 182? Yep. Take another 2 out and I got a 91. Well, 91 is prime, so I can't go any further. But I can take out one group of 2's with 91 going back into the square root. So that will help me now when I go and do my trig functions. So I start with sine theta, then cosine theta, then tangent theta. If you want to do these 3 first so that you know you have plenty of room later, that's fine too. With converting with that square root in the denominator, it gets a little tricky. So if you want to make sure you have room, that's a good idea. The first one, sine, opposite over opposite over hypotenuse will be 6 over 20. No roots there, so I'm good to go. Cosine, 2 square root of 91 divided by 20. Again, don't worry about simplifying the fractions. Those are their real true values, so let's leave it as such. And then for the tangent theta, we have 6 divided by 2 root 91. Of course, we don't like the square root of 91 being in the denominator, so I'm going to multiply top and bottom by, you can do 2 square root of 91, or you can even just multiply top and bottom by the square root of 91. The whole goal, remember, is to get rid of that square root, so we don't necessarily have to worry about the 2 with it, as long as we keep it the same on top and on bottom. So my tangent is going to be 3 square root of 91 divided by 91. And I can't simplify that any further. Then I do the next 3. Sine pairs up with cosecant. Cosine pairs up with secant. And tangent pairs up with cotangent. And again, I'm going to give you the simplified answers on these with the radicals, but get your practice in so that you know what they're going to be. Cosecant is going to be 20 divided by 6. Secant will initially be 20 divided by 2 root 91, but again, we don't like that root 91 in the denominator, so we simplify it and we should get 10 square root of 91 divided by 91. And then our cotangent, again, we're taking from the original, so we have 2 square root 91 divided by 6. Whenever you're using the real values before you do conversions and whatnot, don't simplify the fractions. Again, we're using those exact side lengths. That's why we don't want to simplify here. If you do, it's not the end of the world, but I want to be able to let you guys know that your roots and your side lengths are coming directly from your triangles. All right, go ahead and get a head start on question 3, and we'll join back. This time we were given our a value, which is a root 7. My b value is 9. And this time I'm referencing this angle up in the corner. That is my theta, so it's going to change a little bit. Do our Pythagorean theorem first. A squared plus b squared equals c squared. I don't know c, that's why I'm going to the straight Pythagorean theorem here. Square root of 7 squared plus 9 squared equals c squared. So I get 7 plus 81 equals c squared. Square root of 88. I got 2 and 44, 2 and 22, 2 and 11. I'm only able to take out one group of 2's. And then I had a 2 as well as an 11 still in there, so they multiplied back together to give me 22 in that square root. All right, get started with our SOHCAHTOA. I'm going to erase this work here just so I can have plenty of room. So I have sine theta, cosine theta, tangent theta. Again, we're referencing angle B this time, not angle A. That's if you're going to get anything wrong, that's probably what it will be. Make sure you're referencing the right angle. So from angle B for sine, my opposite is 9 divided by my hypotenuse, which is 2 root 22. I don't like that root 22, so I'm going to multiply by either 2 root 22 or just root 22. And when you simplify and do all that, this should turn into 9 square root of 22 divided by 44. When you go to convert and get that fraction out of the way, that is when you can simplify. Otherwise, if it's not needing a conversion because you don't have a square root in the denominator, just leave your values as is. Moving on to cosine of theta. My adjacent was square root of 7 divided by my hypotenuse. Again, I have a root in the denominator. I don't like that. So I simplify and multiply by root 22 on both sides, and then I simplify. And you will get the square root of 154 divided by 44. And 154 is not able to get broken down in any pairs. That's why 154 stays. And then for tangent, we have 9 divided by root 7. Multiply both sides, or top and bottom, by root 7. And we get 9 root 7 divided by 7. I got the first 3, so I can find the next 3. Cosecant, followed by secant, followed by cotangent. And if you struggle remembering which one pairs with cosecant, which one pairs with secant, if you stick into the SOHCAHTOA, meaning your sign goes first, remind yourself about the ABCs when you look at cosecant and secant, all right? Or if you tell yourself that S and S do not go together, C and C do not go together, so you need to do opposites. Otherwise, if you like so first, you like sine first, then use that first one that comes into the alphabet first. So cosecant would come in first, so that would pair up with sine. Okay, that's one way to remember it. Again, if you want to remind yourself that S's can never be together, C's can never be together, that's another way as well. So for cosecant, I go back to the original sign that I had, and then I flip that because I won't have to worry about any radicals in the denominator or changing it from there. So I should have 2 square root of 22 divided by 9. Secant theta, I start with 2 square root of 22 divided by the square root of 7. That one I can't keep because, again, I have a square root of 7 in the denominator. So I can multiply by the square root of 7 at top and bottom, and I get 2 square root of 154 divided by now a nice 7 down below. And cotangent, root 7 divided by 9. And last but not least, example 4. Label what we know. They gave us B equals 3. They told us A equaled 15. Can't write too well right there. A equals 15. And they're telling us yet again to reference this angle up here in the corner with capital B. So to get started, I need to find out what my C is. So I do A squared plus B squared equals C squared. 15 squared gives me 225 plus 9, which is 234. Then I can take the square root of both sides. 234 breaks into 2 and 117. Believe it or not, 117 does break down into 3 and 39. 39 breaks down into 3 and 13. And that's as far as we can go. So my C is going to be one pair of 3's And then I have a 2 and a 13 left over to give me a 26 back in that square root. Now I have all 3 of my side lengths. Give myself some room here. And we can continue. Start with sine, cosine, and tangent. And remember, we are referencing that angle in the top right corner this time. So every time I pull my opposite, my adjacent, and my hypotenuse, I need to match it up to their respective pieces. So for angle B, I have 3 divided by 3 root 26. Again, don't like the square roots in the denominator, so that is going to turn into, once I simplify, the square root of 26 divided by 26. Those 3's actually end up canceling when you simplify that one. Cosine of theta, I have 15 is my adjacent, divided by 3 root 26. Simplified version when I do that is going to be the square root of 26. Oops, sorry. Yep, it has a 5 with it. Sorry. Had to think on that for a second. And then 26 is in the denominator. So I have 5 root 26 divided by 26 as my simplified answer. And then tangent is a nice number to work with. It's just 3 over 15, opposite divided by adjacent. And it looks like I might run out of room there on the right, so I'm going to just keep going underneath tangent. I got cosecant theta, which would be 3 root 26 divided by 3, followed by secant theta, which is 3 root 26 divided by 15. And then my cotangent theta is going to be 15 divided by 3. So if I ask you for 6 trig functions, I'm looking for sine, cosine, and tangent, and then their reciprocals, cosecant, secant, and cotangent. So all 6 of those. Practice these formulas, these functions. Make sure you know SOHCAHTOA. If that's going to help you remember what side goes where, remember that little study tip, SOHCAHTOA. And then the remaining pieces are their reciprocals.